Hey guys. All right. So here we go with our digital learning adventure. So the first thing on the agenda this week is to go over the quiz from Friday. So I know that some of you weren't there to take the quiz on Friday, and you might have seen in the agenda that there is an online version of it. And so everybody is going to take that online version this week. That's part of your assignment for this week. So you get just a completion grade for completing that assignment. It's also going to count accuracy-wise as a quiz grade. So if you didn't take the quiz yet, if you were absent on Friday, then that will act as your quiz. If you were here on Friday and you took the quiz in class, then I will use whichever grade is higher. So if the one you took in class is a higher grade, that will count as your quiz grade. If this online version that you're doing this week is a higher grade, then that's the one that I'll use for your quiz grade. So what I want to do is go over the quiz from Friday and kind of use that as a quick review of the circles and angles and arc stuff that we did last week. So that's what's up on the screen here. So I already have the answers filled in. I don't want this to be a super long video and a super long review. So I just kind of want to go over a couple things and remind you about a few of the things that we talked about last week before you do that online version this week. So looking at number one, the thing that a lot of people missed on Friday, remember that before you find the radius here, you have to move that 3 to the other side. So we don't take the square root until any numbers that are on the side that have the x and the y parentheses, so that plus 3, that needs to get moved over to the other side first, and then 9 minus 3 would give us 6 on the other side. So the radius then would be the square root of 6. But most of you did really well with the center of this circle. So to find the center, we just do the opposite of these two numbers that are in the parentheses with the x and the y. So positive 5 and negative 12. All right, so looking now at number 2, this one you guys did really well with. There is nothing added or subtracted with the x, so that's where the 0 comes from in the center. And then the minus 2 here gives us a positive 2 for the center of the circle. And there's nothing added or subtracted, so the 25 is good to go to take the square root, and the square root of that is 5, so it has the radius of 5. Looking at number 3 now. So with this one, remember that our kind of general formula for a circle is x minus h squared plus y minus k squared equals r squared. So if the radius is 7, then the number over here by itself is going to be 49, 7 squared. So don't forget, when you're finding the radius, you take the square root, but when you're writing the equation, you're going to square the radius to put it in your equation. Number 4, the minor arc formed by angle 3. So angle 3, let me get a highlighter real quick. Angle 3 is this angle right here, right? So the minor arc, that would be the one that's inside the angle. It's the small one right here. So the minor arc would be this arc right here, which is DF or FD. Either one would be fine. So number 5, the major arc. A lot of people miss this one. The major arc formed by angle 1. So here's angle 1, right? And the major arc is opposite. So the minor arc is this one right here. The major arc is the one, it's the big one around the outside of the circle, the one that's more than half the circle. So the major arc would be this one out here. And in order to name that, you always start with the beginning and end. I'm going to go back to my pen real quick. So we're going from E to F, but we're going the long way. We're passing through D. So that's why we name it EDF. You could have also named it FDE. That answer would have been fine too. But the F and the E had to be on the outside of name because that's the beginning and end of the arc. And then finally here, number 6, arc VTU. So this is a major arc because it has the 3 letters. We're starting at point V, we're ending at point U, and we're going through T to get there. So we're taking the long way from V to U by passing through T. So remember that when you're naming arcs and when you're dealing with major arcs, it's always the edge of the circle. You should never cut through the circle when you're doing an arc. All right. And so then on the back, these were the ones that you had to find the missing measurements for. So a couple of reminders. Remember that the whole circle adds to 360, half the circle adds to 180, and vertical angles are congruent. So those were the 3 big things that you should have used on the back here. So number 7, the whole circle adds to 360. So if we already know the 135 and the 120, when we subtract those from 360, that's where the 105 is coming from. And number 8, half of the circle adds to 180. So if we have 125 degrees, then 180 minus 125 gives us 55 degrees right here. Number 9, so this one is using the vertical angles property. So we were looking for angle HDE, which is right here. So if we know that this arc is 133, then we know that its angle is 133, its central angle. That means the vertical angle, the one that we're looking for, is also 133. Number 10 used the same properties. Number 10 put together the vertical angle and the 180 property. And then you also had to make sure that you were answering the right arc. So we were looking for arc EBD here. So doing the same thing that I did in number 9, 110 degrees out here, puts 110 degrees in here, puts 110 degrees here, puts 110 degrees over there. And then 180 means that this would have to be 70 degrees. So for this one, you could have either added 110, 70, and 110 to get the 290, or you could have seen that you were looking for the whole circle except for this 70 degrees right here. So you could have also said 360 minus 70 to get the 290. Number 11, we were looking for arc JL right here. So you had to find the missing piece in there was 50. You knew all the other parts of the circle except for that little angle that wasn't marked. And so if you subtracted all 4 of those from 360, that's where I got the 50 degrees from. And then 50 and 90 gives us the 140. And finally, number 12, arc PTR. So PTR would be right here. This one, there was a lot of different ways you could have done it. The easiest way is noticing that that's half of the circle. So from P to S is 180 degrees, plus that 61 degrees would give us the 241 degrees. And then the last 2 here, the multiple choice, angle CQD right there is a central angle. Remember that a central angle has its vertex at the center. And segment CQ, this segment right here, is a radius in this circle. So that was those 2 answers. All right, so that was a very quick review of Friday's quiz of central angles. Remember that you're using vertical angles. Half the circle adds to 180, half the circle adds to 360. So you should go take the online quiz. You may use your notes. It is open note, but it is something that you should complete independently. So please don't work with anybody on it or ask anybody for help. It's something that you need to do on your own. All right, so good luck with that, and I will see you when we take notes later this week. All right, bye guys.